The length of a shadow of a tree is 170 feet when the angle of elevation of the sun is 35 degrees. Approximate the height of the tree, round to one decimal place. We're given the length of the shadow is 170 feet, and so from the base of the tree, I marked 170 feet across the ground. The angle of elevation is 35 degrees, so from the ground, if you move um, up an angle of 35 degrees, then that gives you a line of sight that would be the hypotenuse. We are after the height of the tree, so I highlighted it with orange so that it would show up on paper and we could discuss it in the video. With respect to 35 degrees, x is opposite, the shadow is adjacent, so that's a perfect case for tangent. Tangent of 35 degrees is equal to x over 170. If we multiply both sides by 170, then we have 170 times tangent of 35 degrees equals x, the length of the shadow. Make sure you're in degree mode when you type this in, and you'll get an approximate tree height of 119 feet. A radio station tower was built in two sections. From a point 87 feet from the base of the tower, the angle of elevation to the top of the first section is 25 degrees, and the angle of elevation of the top of the second section is 40 degrees. Find the height of the top section of the tower. Okay, so this blue triangle that I outlined, it's the one that has the first angle of elevation in it, 25 degrees. Opposite of it will be the height of the first section of the tower. In both cases, we are told that we are 87 feet from the base of the tower, and then we have our different angles of elevation. So let's start with a smaller blue triangle. Tangent of 25 degrees is equal to opposite over adjacent, so that's y over 87. Solving for y, multiply both sides by 87, and so y, which is the height of the first section of the tower, is 87 tangent of 25 degrees. You can approximate that with your calculator if you'd like. What we're going to do is we're going to use that to find this upper section, x. This orange little segment here is the answer we're after from the problem. Now, since we know y has an exact value of 87 tangent of 25 degrees, now look at the big triangle. X plus y is opposite of 40 degrees. 87 feet is still adjacent, so we can set up a trig ratio using the big triangle, and we can write that as tangent of 40 degrees is equal to x plus y over 87. Multiply both sides by 87. Actually, let's hold off on that. This x plus y, remember, we can write y as its value. So I left it light blue because y is equal to 87 tangent of 25 degrees. So actually, we can replace y with its value from that smaller blue triangle. Now, let's go for the final answer. After replacing y with its exact value, multiply both sides by 87. 87 tangent of 40 degrees is equal to x plus 87 tangent of 25 degrees. Subtract 87 tan 25 on both sides, and our value of x, the exact value, is 87 tangent of 40 degrees minus 87 tangent of 25 degrees, which is approximately 32.4 feet. Solve the right triangle where angle A is 25 degrees and side A is 16 feet. Okay, so we've got a right triangle at the right of your screen. I've labeled angles A, B, and C with capitals. Angle A is 25 degrees, so I've already put that in. Side 16, that's opposite of angle A. Side A is 16. Let's go, let's get this third angle. Anytime you know two angles, the third one has to make the total 180. So angle B is 180 degrees minus the right angle 90 degrees minus the 25 degree angle it was given, and that leaves 65 degrees for angle B. Whenever you work these problems, you want to try to use exact values that are given or exact values that you've calculated. Most of the time, the final answer is going to involve an approximation, and you just have to be careful about approximations. Okay, so in class, you guys decided to work with the 65 degree angle, and you wanted to find side B first. 16 is a side we know it was given, so from 65 degrees, B is opposite, 16 is adjacent, so we can set up tangent of 65 degrees is equal to B over 16. Multiply both sides by 16, and you get side B. 16 times tangent of 65 degrees. A few of you asked about using the 25 degree angle. It's totally appropriate. 16's opposite, B is adjacent. So if you use 25 degrees and tangent, you're going to need to set it up as tangent of 25 degrees equals 16 over B. Either way is fine, and they will get you to the correct answer. When you multiply this bottom one, if you take this route, which is fine, you'll multiply both sides by B, and that gives you B tangent 25 degrees equals 16, and you'll have to divide by your tangent of 25 degrees. Again, it's not wrong. It's approximately 34.3 either way you do it. If you choose this top path, then the only operation you have to do is multiply both sides by 16. So it's one step faster, but it's not going to make or break your problem by any means. The only thing left to find is the hypotenuse. From 65 degrees, I'm going to scroll back up one more time. From the 65 degree angle at the very top of your triangle, 16 is adjacent, C is your hypotenuse, so you guys picked cosine of 65 degrees equals 16 over C, and that was well done. That's exactly how you do it. Cosine of 65 degrees is equal to 16 over C. Multiply both sides by C in order to eliminate your fraction. C times cosine 65 degrees equals 16. Divide both sides by your trig expression. 16 divided by cosine of 65 degrees is 37.9 feet, and that is labeled in the parentheses. And let's do one more. This time we'll be given two sides. Solve the right triangle where side A is 26 feet and side C is 45 feet. I try to keep my labeling consistent for you guys. Like I usually try to always make my right angle C. A and B, those can really float around anywhere. But anyway, for consistency, I try to put them in the same spot for you. We're given side A, which is opposite of angle A, as 26, and C, opposite of the 90, that's the hypotenuse, 45 feet. The only side left that we don't know is the adjacent side, or side B, the one opposite of angle B. We do know that 26 squared plus B squared equals 45 squared. We could set this up with a Pythagorean theorem. Remember, your hypotenuse is always on one side by itself. Subtracting 26 squared on both sides, we have 45 squared minus 26 squared. And then to get the square to come off of the B, where it's just B, we take the square root of both sides. and we get an approximate length of 36.7 feet, and that's in the parentheses. Now, the only things left to solve are angles A and B. In class, you guys told me to go after angle A first, so that's what we did. From where angle A is located, and it's a good idea not to use a rounded number so you maintain accuracy towards the end. You guys said it was totally fine to use sine of A because that would be opposite over hypotenuse. Sine of A is 26 over 45. And anytime you need an angle, you invert your trig function. So sine inverse of our 26/45 ratio gives us an angle a little bit more than 35 degrees. Now that we know angle A and C is a right angle, we can take those two away from 180, and that's angle B. And that's what we did in orange. I'm going to pan this out just a little bit. There we go. I hope this video has helped you out. If you have any questions, please feel free to reach out by phone or email. If we're on campus together, stop by the office and I'll do my best to help you out.